Imagine a future where astronauts land on Mars, explore its surface, and return to Earth, powered by fuel they create right on the red planet itself. Sounds like science fiction, right? Well, not anymore. In today's video, we're diving into the cutting-edge science of creating fuel on Mars. From using the Martian atmosphere to harvesting resources from the soil, these technologies could hold the key to humanity's future in space. So, how do we turn Mars into a self-sustaining launchpad for interplanetary travel? Let's find out. The dream of humans living and working on Mars is closer than ever, but one of the biggest challenges in making this vision a reality is fuel. Transporting enough fuel from Earth to Mars for a round-trip journey is impractical due to weight and cost. The solution? Creating fuel on Mars itself. This revolutionary concept, known as in-situ resource utilization, ISRU, is key to enabling sustainable exploration and eventual colonization of the red planet. Spacecraft launching from Earth carry every resource they need, from food and water to oxygen and fuel. However, the further we venture into space, the more self-reliance becomes essential. On Mars, fuel is needed not just for return trips but also for powering vehicles, equipment, and life support systems. By producing fuel on Mars, missions can reduce dependency on Earth, lower costs, and increase safety by ensuring a reliable supply. Creating fuel on Mars involves leveraging the planet's natural resources, its atmosphere, soil, and even water ice. Here's how. Mars' atmosphere is over 95% carbon dioxide, making it an abundant resource for fuel production. A process called the Sabatier reaction can convert carbon dioxide into methane, CH, and water, HO, using hydrogen. Methane is an excellent rocket fuel and is also compatible with existing engine designs like SpaceX's Raptor. Mars is home to large quantities of water ice, particularly at its poles and beneath the surface. Using electrolysis, water, HO, can be split into hydrogen, H, and oxygen, O. While hydrogen can combine with carbon dioxide to create methane, oxygen serves as an oxidizer, essential for burning rocket fuel. NASA's Perseverance rover has already demonstrated a groundbreaking technology called MOXIE, Mars Oxygen In-situ Resource Utilization Experiment. This device extracts oxygen directly from carbon dioxide in the Martian atmosphere. Oxygen is not just vital for breathing but also forms a significant part of rocket propellant. Martian soil, or regolith, contains minerals that may be used to support fuel production. For example, perchlorates in the soil could potentially be processed into oxygen. Although this is a developing area of research, it shows the potential of using every available resource on Mars. While the concept is promising, there are hurdles to overcome. Producing fuel requires significant power. Solar panels, nuclear reactors, or a combination of both would need to supply energy in a consistent and reliable way. Demonstrations like MOXIE are proof of concept, but scaling these technologies to support human missions will require robust, efficient systems. Mars' harsh environment, with extreme cold and dust storms, can degrade equipment. Designing machinery to withstand these conditions is critical. The ability to create fuel on Mars offers multiple advantages. Cutting down the amount of fuel launched from Earth makes missions more economical. On-site fuel production enables longer stays and more extensive exploration of Mars' surface. A sustainable fuel source is a cornerstone for establishing a permanent human presence on Mars. Organizations like NASA, SpaceX, and ESA are investing heavily in ISRU technologies. NASA's Artemis program and SpaceX's Starship missions aim to integrate fuel production capabilities into their Mars strategies. These developments are not just about Mars, they represent a leap forward in humanity's ability to thrive on other planets. Creating fuel on Mars is a transformative idea, turning the red planet from a destination into a launchpad for further exploration. By harnessing Mars' resources, we're not just solving logistical problems but opening the door to a new era of interplanetary living. The next giant leap for humanity might not just begin on Earth, but on Mars itself. Creating fuel on Mars is no longer a distant dream, it's a challenge we're actively solving, step by step. With every breakthrough, we move closer to a future where Mars isn't just a destination, but a stepping stone to the stars. If you're excited about humanity's journey to Mars and beyond, don't forget to give this video a thumbs up and share it with fellow space enthusiasts. And if you want to stay updated on the latest in space exploration, hit that subscribe button and turn on notifications. Together, we'll keep reaching for the stars. See you next time.